हेलो, आई शशि भूषण तिवारी वेलकम यू ऑल टू दिस चैनल। आप में से जो लोग नए हैं उनको बता दूं कि मैं इस चैनल पर लगातार जेई एडवांस्ड एग्ज़ाम्स के लिए आपको टिप्स, ट्रिक्स और कॉन्सेप्ट्स बताता रहता हूं। आज के इस वीडियो में हम इलेक्ट्रोस्टैटिक्स के ऊपर बेस्ड एक क्वेश्चन करेंगे, जिसको मैंने फॉर्मेट किया है एक एमसीक्यू के रूप में, जिसमें एक या एक से ज़्यादा आंसर्स करेक्ट हो सकते हैं। क्वेश्चन थोड़ा ट्रिकी हो सकता है, पर बेहद मुश्किल तो नहीं कहा जाना चाहिए। आइए समझते हैं हमारे आज के इस क्वेश्चन को। इलेक्ट्रोस्टैटिक्स पे बेस्ड ये क्वेश्चन आपसे कहता है कि देयर इज अ मेटल स्फीयर ऑफ गिवन रेडियस आर। देयर इज अ मेटल स्फीयर ऑफ गिवन रेडियस आर। नाउ दिस मेटल स्फीयर is sliced into two parts. You cut the sphere along a circular surface like this. This part is separated from this part. Now, a thin layer of insulation is placed between these two parts, and these two parts are again stuck together. You place a thin layer of insulation here. You place a thin layer of insulation here, and please be mindful, this face is a circular face, this face is a circular face. Now you again bring the two spheres close and just place them like this. So there is a very thin layer of insulation between these two cut portions, and you are allowed to assume that the spherical shape of the surface is maintained. There is not much change in the spherical surface. The radius is r, it is given to you. Now the question says that a charge, positive charge q is given to this smaller part of the metal sphere. This whole sphere has been cut into two parts, and now the smaller part is given a charge q. It is also given to you that the surface area of this smaller part, curved surface area of this smaller part is pi r square, where r is the radius of the sphere. So I repeat, the area of this curved surface of the smaller part is pi r square, where r is the radius of the original sphere. Let me once again repeat the important points before I ask you the question. The curved surface area of the smaller part is pi r square. The insulation layer is of negligible thickness. This white colored part represents the insulation layer, and the smaller part has been given a charge capital Q. So this is given to you, and now the question gives you exactly 4 options. You have to tell which of these 4 options, one or more of them may be correct actually. So you have to tell which of these 4 options are actually correct. So these are your 4 options. The first option is the force between the charges on the two flat circular faces is 3q square by 8 pi epsilon naught r square. Read this statement carefully. Force between the charges on the two flat circular faces. What is meaning of flat circular faces? If you cut this sphere into two parts, this is one part, this is the flat circular face. It is having some induced charge on it, and then there is other part of the sphere. This is also having a circular face of same size. In between them there is a layer of insulation. So this flat surface is having some charge, this flat surface is having some charge. Force between those two charges, which happen to be on the flat circular faces of the two parts, is the force equal to this much or not? This is what you have to decide. Then the second statement is electrostatic energy of the entire charge system is nearly q square by 8 pi epsilon naught r. For the entire charge system, the electrostatic energy is q square by 8 pi epsilon naught r. The two parts of the spherical surfaces have different charge density. The two parts of the spherical surfaces Spherical surfaces means these surfaces. So, whether this part and this part has same charge density, that is what you have to decide. And the last part says the spherical surfaces, the spherical surface of the smaller part has higher magnitude of charge density on its surface compared to the bigger part. That means C and D are more or less asking you one thing only, something about charge density on the spherical surface of the two parts of the sphere. So, I think question is very clear to all of you, and you all can pause the video right now and give it a try. I am getting out of the screen for a moment. You capture the entire question, take the screenshot and definitely give it a try. Here I proceed with my explanation. So, this is the situation that has been given to you. A charge plus q has been given to this part of the sphere. Just for the sake of clarity in diagram, I have increased the gap. This black colored gap is actually insulation. It is filled with insulation layer. Okay, that's fine. So, if this part is having charge plus q, will the entire charge reside here? The answer is obvious, no, not at all. Some charge, some part of this charge will go to the inner circular face. This is the flat circular face. So, some part of charge will go here. Let me call it as q. I hope all of you can understand that the front face, that the face that is in front of this circular face, I mean this face, this wall, will have charge of minus q on it. In fact, this gap with two metal walls, there is nothing but a capacitor with some dielectric field in between. One surface of the capacitor, one plate of the capacitor is having charge plus q, small q, and the other one is having minus q. You can argue that if this charge is q, this has to be minus q. Remember, it is given that this is a very, very thin separation. So, it is a kind of ideal parallel plate capacitor having circular plates with a very small gap between them. So, just the way you solve this kind of problem, if I give you two parallel plates like this and I put some charge q1 over here and q2 over here, how do you find the charge distribution on the four faces? Arguing in similar manner, you can convince yourself that if charge is plus q over here, then minus q charge has to be here. Think in terms of some Gaussian surface, you will be able to convince yourself, right? So, obviously, if this is plus q, this is minus q, which means this part of the sphere is actually neutral. So, if a minus q charge has been induced here, this curved surface will have overall charge of plus q on it. That is guaranteed because this is neutral. This part was given a charge capital Q. Out of capital Q, plus q is present here, that is what we are assuming. So, this curved surface or the spherical surface will have a charge of q minus q on it. I hope all of you can agree to this, right? Now, actually you can proceed in two ways. You can say that because of charge on these circular faces, there cannot be an electric field here or here, no way. In the theory of parallel plate capacitors, you have studied that if these two plates are placed close enough so that they can be treated as infinite surfaces, then electric field is exactly perpendicular to the plate surfaces. There is no electric field produced because of this charge and this charge outside the plate. In practice, there is some fringing over here, but if this gap is really small, we ignore that and we assume that this plus and this minus charge can produce field only between the parallel plates of the capacitor. These two charges cannot have a resultant field here, it is very easy to see. Similarly, these two charges cannot have any field over here. So, these are two parallel faces having charge plus q and minus q. This set of charge plus q and minus q together they both of them, they cannot produce any field here or any field here. That is one thing. But because it is metal, so electric field here has to be 0. So, electric field because of these two small q charges is 0, which means electric field due to this charge present on the spherical surface must be 0 here. Because of this charge, the electric field must be 0 here. Because of this charge, electric field must be 0 here, here and here also. Because of these two charges, electric field is 0 obviously at all these points. So, because of this charge, the electric field here, 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 here has to be 0, because at any point inside the metal, the resultant field will be 0, which implies that this entire charge is arranged such that it produces 0 electric field at all points inside the spherical surface. The total charge that is present on the surface is actually capital Q. This plus Q minus Q, overall it is 0. So, Q minus Q and Q, they add up to capital Q. So, capital Q charge is present on the entire surface and it has been distributed such that it produces 0 electric field at all inside points. We all know that this is possible in only one manner, when the charge is distributed uniformly on the surface, full stop. So, a capital Q amount of charge is distributed uniformly on the surface as if it is a complete sphere. More or less this is true. So, capital Q charge is distributed uniformly on this surface and the surface area of this part is pi r square. According to the question, surface area of this spherical part is pi r square. So, surface area of this part is 3 pi r square. Overall surface area of the entire sphere is 4 pi r square. So, obviously, if the charge density is same everywhere and this area is 1/4 of the total area, so the charge that is present here, which is Q minus Q, that has to be Q by 4, isn't it? And remaining 3/4 of the charge is present here. So, this charge is 3Q by 4. So, charge on this spherical surface is Q by 4, charge on this spherical surface is 3Q by 4. This is easy to argue actually. This is what is going to happen. Well, you can argue it like this also. Think in terms of energy. Think in terms of energy. This plus Q and this minus Q charge, the set is making a capacitor. What is energy stored in this electric field between the capacitor plates? It is Q square by 2C. Because the separation between these two is extremely small, D is very small, therefore, capacitance epsilon naught A by D is very large. If the capacitance is very large, we can safely say that this energy is almost 0. So, energy of this charge capacitor is very small, it is 0. What about energy of interaction of these charges with these charges? It is 0, because if these charges on the surface, let us say make a potential V1 at this point, V1. If you take a small charge plus dq here, its potential energy will be this much, but almost at the same location you have a negative charge minus dq. So, because of these charges, if the potential here is V1 plus dq and minus dq, the pair of charge will have no potential energy. So, interaction energy of this charge with these charge. Basically, this is zero charge. What I am saying is plus q and minus q are almost at same location. So, interaction of this with this is not producing any energy. So, in the gap, we are saying that there is negligible energy. We are saying that this charge interacting with this charge produces almost no energy. So, where is the energy of this electrostatic system? Where is the energy? It is just equivalent to a spherical ball of radius r having charge q. The total charge here is 0. So, the total charge present on the surface has to be q. But okay, how can I say that this is exact, that thing is exactly same as this? There is a layer of insulation in between, blah blah, comes to our mind. But the fact remains that overall charge is q. Now, any system left to itself will try to minimize its energy. Okay. So, this charge q has to be distributed on this surface so as to minimize its energy. And the only way in which this charge can distribute itself so as to minimize its energy is to spread itself uniformly, as it happens in the case of a sphere. So, there is no reason that it won't be uniformly distributed. If you are not convinced with this logic, again let me put it like this, that these two charges do not produce any electric field here, nothing. So, the charges on the surface, they do not experience any electric force due to these charges. No. So, if these charges are not experiencing any kind of force due to these charges, so obviously on the surface of a sphere, the charge will spread uniformly only. So, the charge on the surface is uniform, right? Charge on the surface is uniform. I have written how much charge is present here. I have told you how much charge is present here. So, I think few parts of the questions have been answered. I think this one has been answered. The system is equivalent to, as far as energy is concerned, it is equivalent to a uniformly distributed charge q on its surface. So, this one appears to be correct. Two parts have different charge densities. This does not sound good. Higher, this also does not sound good. So, only part that is left is force between two charges on the two flat circular faces. Here you can make one simple mistake, I would say, but yes, you can make that mistake. So, I am not doing it for you, but be careful. If this surface area is 1/4 of the entire surface area of the sphere, don't think that this angle is 90 degree. No, this is 120 degree. Area of this cap, it is a cap sort of thing, right? Area of this cap is given by 2 pi r square 1 minus cos theta. Those of you who understand a bit about solid angle must be knowing this. If you take a cone with a semi-vertical angle theta, starting from the having its apex at the center of the sphere, then the cone cuts the sphere and you get a cap kind of thing. This thing is nothing but something of this shape. We are talking about surface area, this surface area. This surface area is given by this. So, when this surface area is equal to pi r square, cos theta will be equal to 1 by 2. Theta is 60 degree, so this angle is actually 120 degree. This theta is 60 degree. So, if this is r, radius of this thing, the circular face on which you are having that small q charge, this is how charge is placed over here, small q charge. So, radius of this thing, this r, is basically r sin 60 degree, which means root 3 by 2r. So, if you are thinking that it is a capacitor, this capacitor is having two circular plates having a very small separation between them, and charge present here is known to you small q, we have already calculated that. And the area of this circular plate is pi r square. Keeping this in mind, calculate how much force one circular plate of capacitor will exert on the other circular plate. And please write in the comment section whether this option is correct or not. I hope that I was able to explain this question to all of you, and most probably many of you have learned few good things. So keep watching this channel, do like the video. See you in the next one.